From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donnfelker.
And I'm Kaushik Gopal.
Welcome to the show.
But before we kick it off, I want to thank Mapbox for sponsoring this episode. What is Mapbox? Mapbox is the location data platform that enables developers to go off and build their app experiences. They offer complete map design control, allowing you to create beautiful custom maps. But it's not just about maps. If you had any location components in your app, and most apps these days do, Mapbox would handle all of these needs flawlessly. Their Android SDKs give you a ton of functionality like driving, walking, or biking directions, location search, geocoding, reverse geocoding, which is pretty cool, geospatial analysis, which is extremely cool. Their SDK helps with all of this. And the beauty is that this can be done with Mapbox in just a few lines of code. With just a few lines of code, you can display accurate turn-by-turn driving, walking and biking navigation, real-time traffic. I mean, they handle all of the location needs, so we can just focus on building our app. Many companies and developers already integrate Mapbox today in their Android apps. I know, because we use them here at Instacart. So just head on over to mapbox.com/Android. That's mapbox.com/Android. Sign up there, and the first 50,000 unique mobile users is free. You don't even have to worry about pricing because they have a pay-as-you-go model. Thank you for sponsoring today's show, Mapbox. In this mini-fragment episode, Donn fights the good fight and continues with our series Effective Java. The third edition of Effective Java by Joshua Block was recently released, and with it, some of these items were updated. So Donn has gone back and made sure that some of the earlier items that we did were not missed out. In this one, he tackles item 9, which is a new one. Prefer try with resources to try finally. I'll let Donn do the honors. So listen on.
In today's episode, I'm going to be talking about item number 9 in the Effective Java 3rd edition book. Previously, we were working with the 2nd edition of the book, but the 3rd edition recently came out. Now, thankfully, a lot of these things are the same, but there have been some new items that were introduced. On the last episode of the Fragmented podcast, where we talked about Effective Java, I did the item number 5, which was also recently added in the 3rd edition. Today, we're going to talk about item number 9, which is also another new addition. So let's hop right into it. Item number 9 is titled Prefer Try with Resources to Try Finally. Now, many Java libraries include resources that must be cleaned up and closed by manually invoking some type of close method. And good examples of this are things like the input stream, output stream, SQL connections, and various different types of things that you're going to work with that require some type of close mechanism. Now, unfortunately, closing resources is often overlooked by clients, which can result in memory leaks and all different other kinds of problems and performance consequences. So what we've always tried to do at that point in time is wrap these different types of things in try finally statements to guarantee that a resource is closed properly. This is nothing new. It's what we've been doing for years, for as long as we probably can remember, and some of us have long as all of us have been coding in that case. And it's very simple. Let's take the simple example of maybe reading the first line of a file. We're going to open up some type of reader, which is, maybe some type of stream. We're going to go ahead and then read that line, and we're going to close it out. And we would do that by surrounding the read line method with a try finally statement. And in the finally statement, we would just close the reader when we're done with the line. So that doesn't look bad. We've probably done this. You probably have this in your application right now. Nothing wrong with it, really. What really ends up happening is it really starts getting ugly when you have to do that with more than one resource. And what would be a good example of that? Well, simply just copying a file. I want to copy one file to another file, so I provide a source file path and a destination file path. Now, in order to do that, I'm going to need something like an input stream to read data from, and then I'll need an output stream to write the data to. So these are two different resources that do need to get cleaned up. So traditionally, what you would have to do in this situation is create one try finally statement, and inside that try finally, you would work with the input stream, and you would then at that point be able to read from the input stream. But then if we wanted to write to it, we'd also have to create an output stream inside of that try statement. So we're kind of creating these nested try finally statements. And So inside of that next try finally statement, we would actually then be doing all of our reading and our writing and so forth to the other, the output stream, so we can actually copy that file. Now, again, this doesn't look too terrible, though it is kind of verbose, but it does actually pose a few problems that we can run into. We'll talk about here in a second. Now, one thing that I found interesting here, and this is probably these next two paragraphs are the most important in this entire little section here. And Joshua states it may be hard to believe, but even good programmers are wrong most of the time. Again, that's up for argument, but that's kind of the truth, is that we all do miss things from time to time, and it's very easy to let these little tiny things slip by. And one of the things that's really interesting to me is that we really respect a lot of these things that we saw in the Java Puzzlers book. And on page 88 of that, and this is inside of the Effective Java book where he states this, is on page 88 of the Java Puzzlers book, no one noticed for years that what was on that page was wrong. So for years, it was never even brought up that it was wrong. And in fact, 2/3 of the use cases of the close method in the Java libraries were wrong in 2007. Let that sink in. 2/3 of the uses of the close method in the Java libraries were wrong in 2007. So that's just mind-boggling how much of that code was out there, probably copied from documentation, and it was wrong. It's one of those things, even people who wrote the documentation or wrote those things got it wrong. Again, traditionally we use the try finally for closing out these type of statements, but even that's easy to mess up. So one of the things that really makes, when we start nesting these try finally statements, really complex is this little weird subtle deficiency, as he states in the book. And I don't know if I'd even call it subtle. I'd kind of call it a huge glaring problem. Now, again, we have these two try finally statements. One is inside of another try finally because we're kind of reading from a file and then we're going to write to another file destination. So this is like a copy method. Now here is this next paragraph. I have tried for the life of me to rewrite it so it was my words instead of Joshua Block's, but it is written so succinctly and so perfectly that I can't do it justice. So I'm just going to actually quote this here. This is from the actual book itself. And Joshua writes, in quotes, "The code in both the try block and the finally block is capable of throwing exceptions." So again, the try block, this is me kind of going off the cuff here. The try block, we're reading a line from a file. In the finally block, we kind of close off that stream. So in the first part of the method, we actually read the first line of the file by calling the readLine method. Now that could throw an exception because of a failure in the underlying physical device. And then the call to the close, which is inside the finally block, could fail for the same reason. So there could be a problem with the device at that point. Now, under these exact circumstances, the second exception completely obliterates the first one. Let that sink in. We encounter an error where we're reading a line of a file. Now that's in a try finally. That throws an exception, which immediately would then invoke the finally statement, right? Well, again, we encounter another physical device issue, so the close method would then fail for the same reason. So that second exception masks the first problem that, hey, we couldn't read because we couldn't get to the disk for whatever reason. So there's no record of that first exception anywhere in the exception stack trace. It's just not even there. Now, I don't know about you, but this can completely be confusing and make debugging a real system near impossible. So it's because, and some people are going to say, well, why is that going to be? Because usually it's the first exception that we want to see in order to diagnose the problem. Just like when you get a stack trace inside of your Android application, you look inside of Logcat and you look through and there's a big long stack trace. You look at the stack trace and you trace it back to where the origination happened. You go, oh, well, that's the method or that's the line that this error that caused this error. Now let me figure out why that error occurred on this line. Well, just imagine if that last part of the stack trace wasn't there. How would you really know that that was the area that caused the problem? You wouldn't. So it'd be really difficult to solve. So while it is possible that you could write some code to suppress the second exception in favor of the first, as Joshua states here, no one really did it because it was, in fact, just too verbose. And personally, in my opinion, I bet you most of folks just completely forgot. This is just one of those weird things that if you don't know about it, if you've never encountered it, if you've never studied this, then you would never really know to do this. And this is something that, that all of us learn over time, that the more that we do know, the more that we realize that we don't know. So it's very, very interesting. Thankfully, in Java 7, they introduced a try with resources statement. Now, to be able to use this construct, a resource must implement the auto closable interface. Now, the auto closable interface is just a single method interface. So it has a single method inside of it. It has a void return on it, and the method name is close. Now, so basically anything that needs to be closed should just implement the auto closable interface or extend it in some way. So thankfully, many of the classes and interfaces in the Java libraries and in a lot of the third-party libraries, thankfully, now implement or extend auto closable by default. So if you write a class that represents a resource that must be closed, maybe you're handling a large file, bitmaps or cameras or sockets or whatever, you might want to implement auto closable as well, so you can easily use try with resources, that new statement. Now, previously, when we were looking at actually copying a file, as I had said before, and we kind of nested these try finally statements, we had to kind of stack them in there accordingly. And this ended up being close to 20 plus lines of code with the new lines and all the brackets. And I'm not inflating anything. That's just kind of what it is here on the screen. It's about 20 lines. Now, the try with resources, with multiple resources, so we're going to be copying the file, same thing. We're just copying one file from a path to another destination. That kind of cut that down to a little bit less than half of that. So about 9 lines of code right now, which is amazing, in my opinion. That's great. So we can a lot less code. And it's very simple to use because we're just you throw out the word try, and then you put basically the resources that you're going to be using inside there, and you have a block that you can work within where you can do all of your work. And if anything happens, it's automatically going to be handled for you. Things are going to be cleaned up for you. The close method is going to be called because it implements the auto closable interface. Now, the cool thing here is now that the exceptions aren't going to be just like blown away and obliterated here. So, for example, if we're reading a line from a file on the first method before we can actually write it to another file or whatever, and that causes an exception, what will happen is the call to close may happen, and that may also throw another exception, just like we had before. So we're reading a line, something happens to the disk, we get an exception. We try to call close, we get another exception, and that's actually because of the disk again. So we get 2 exceptions during this path here. Now, in that case, the latter exception is suppressed in favor of the former, meaning that the close exception is going to be suppressed, and we're going to actually get the first exception that caused the issue. So maybe the read line method, which is what we want. So in fact, we have multiple exceptions that may be suppressed in order to preserve the exception hierarchy that we actually want to see. So this is humongous here. We don't have that problem that we had before as long as we're using try with resources. Now, these suppressions are not actually just like discarded, like hopefully you don't think they are. They're actually kept around and printed in the stack trace with a notation saying that they were just suppressed. Thankfully, also in Java 7, a get suppress method was added to the throwable class, meaning that you can actually programmatically pull out the exceptions that were suppressed. So for whatever reason you want to know which ones are suppressed, you can actually pull those out as well. Now, just as with the try finally statement, you could put catch statements inside of there to catch clauses, inside of the try finally statement. So you can actually catch the exceptions and perform different logic inside of there. You can do the same thing inside of the try with resources. So let's use the same type, a similar type of example where we're going to read the first line of a file and we want to return the first line of the file. Maybe it's a CSV file. We want to return the headers for whatever reason. If for some reason we kind of run into an IO exception during reading that first line of the file, something just happens, physical device, something wrong with the file, it's corrupted or something like that, we get an IO exception, we maybe just want to return a default value. Maybe it's an empty string. Maybe it's just something else. You can still put a catch clause inside of a try with the resources. So it's super easy to do. It's just like try finally. But again, because these different resources implemented auto closable, all of the errors and handling and exception hierarchy, all that's going to be maintained for us. And it's actually much less verbose. It's much more succinct. It's much more easier to read. It's less than half the code. I mean, who doesn't love less code? So to really wrap this up, we always try to want to use try with resources in instances where we have and where we're working with resources that must be closed. So in the end, the code's just going to be shorter. It's cleaner. It's easier to read. We're going to get the exceptions that we want. They're going to be useful. And it's just fantastic. So, I mean, I'm not saying don't stop using try finally. There's still many use cases for it. But if you're working with something that does need to be closed, make sure that you're using try with resources, the statement, And then if for some reason it doesn't, you can use try finally. And again, if you're writing a library or you're writing something internally that needs to be closed, make sure you implement auto closable, and then you can go ahead and use try with resources, and that would be super easy. So again, to wrap it up, this is item number 9. Prefer try with resources to try finally.
Once again, we want to thank Mapbox for sponsoring today's show. Mapbox handles all your map and location needs, so you can focus on just building your app. With their simple APIs, they provide the easiest way to build a customizable map experience in your Android app. Driving, walking, biking directions, location search, geocoding, reverse geocoding, they got it all. Head on over to mapbox.com/Android to get started. Thank you so much for sponsoring today's show, Mapbox. That's it for the show, folks. Fragmented is hosted by Donnfelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.